Hi, this is the video for Practica3 and it's about baking dough. Its contents are first introduction, then methodology, results presentation, discussion and analysis of results, and lastly conclusions. The objective for this practice is to analyze the effect of fermentation time on the rheological properties of baking dough. As for the introduction, once you mix bread flour and water together, a protein called gluten is formed. This protein has unique viscoelastic and adhesive properties which give the dough its elasticity. The mixture quickly hydrates the flour's molecules and forms structures called gluten strands. Kneading or applying shear stress to the dough aligns said strands and creates a gluten network. This network allows air to be incorporated in the system and improves elasticity and resistance to stretch. When yeast is added to the dough, the result is called leavened dough. This is because this microorganism converts sugar into carbon dioxide through a process called fermentation. The carbon dioxide is then trapped within the gluten network, which results in a risen dough with improved elasticity. The equipment we use to obtain the data for this practice is called a texture analyzer.
Now we will talk about the methodology for this practice. So the first part was making the dough. The first step was to add 310 grams of flour in a bowl. Then we made a hole in the center. In this hole we added 100 milliliters of water at 25 degrees Celsius, 8 grams of salt, and 20 milliliters of extra virgin olive oil. We mix of the ingredients and knead until the dough is fully integrated. Uh, in our case, the dough was still dry, so we added 40 milliliters of water and 5 milliliters of olive oil, and we kept kneading. The next step was to take a small portion of the dough for texture analysis. Then we diluted the yeast in 60 milliliters of water, also at 25 degrees Celsius. We added the yeast solution to the dough, and we took a small portion of the dough just as the yeast was added, and then every 5 minutes. The second part of the practice was the texture analysis. So first we turned on the texturometer, then we sampled the 5 kilogram load cell. After, we opened the software in the computer, which is called Exponent. Then we click on Menu, Type of Product, Bakery, Biscuit Dough, and we load the project. The fifth step is to add the accessory, which is a cylinder of 10 millimeters. Then we have to calibrate the equipment. The seventh step is to click on Test, Configuration, we name the project, and we add the type of test. Then we run the test with a distance of 45 millimeters, and finally we run the macro.
Now I'm going to show you the results. First, we have the texturometer results for time versus force applied to dough with yeast and without the yeast. In the first graphic, we can see the results for the first day of the analysis, and in the second one, we can see the results for the second day. Here are a comparison of the results for both days for the next analysis we are going to do. And here we have the texturometer results for time versus force applied for baked bread with crust and a piece of bread. And also we have the texturometer results for strain versus force for the whole baked bread and the piece of bread. The discussion and analysis. For the first graphic, according to the results of the TPA texture analysis for the first day, it can be seen how the curve of the dough without the yeast has a much higher hardness peak than the one with the dough with the yeast. It can also be seen how the first negative peak is larger for the yeast dough than for the unleavened dough, which means that the thickness is greater for the yeast dough. In neither of the two curves is a fracturability peak observed, which will be before the hardness peak. And finally, neither curve has a second peak to calculate the cohesiveness of the sample. For the second graphic, we can see that according to the results of the TPA texture analysis for the second day, the first thing that can be emphasized is that it has a similar behavior to the results of both dough samples for the first day, since the peak hardness of the unleavened dough is still higher than of the yeast dough. However, the peak hardness of the dough without the yeast increased significantly compared to the first day value, and the peak hardness of the dough with the yeast decreased compared to the first day. Besides, the thickness peak is now higher for the dough without the yeast. Uh, what will be the behavior if the texture test were taken after 36 hours of having prepared the sample? If we see the graphic that analyzes the four curves, we can see that when the test was carried out on the second day, the hardness decreased for the dough with the yeast compared to the first day, and increased for the dough without the yeast. Also, the hardness can be seen in the first peak, as I mentioned before. Uh, but if we are going to estimate if a tear proof is carried out after 36 hours, the hardness of the yeast dough will gradually decrease, while the dough without the yeast will gradually increase. Now we have the discussion and analysis for the other two graphics that analyze the baked bread. According to the results of the first graphic, we can see that there are oscillations in the data of both curves. It can also be seen that the curve of the baked bread complete with the crust has a higher fracturability peak, and that the hardness peak is also higher than that one of the bread without the crust. The oscillation in the data may be due to air spaces in the interior of the bread, and finally, the difference between hardness of both samples may be due to the fact that one sample includes the crust and the other is only the analysis of the internal part of the bread. Um, Now, the analysis of the second graphic, that in which the relationship between force and effort can be analyzed. In the red curve, you can see that there is a piece at the beginning in which a linear relationship between force and strain is shown, in which can analyze the deformation of a breed sample. Both curves oscillate and have several peaks. And finally, when the force is increased, the deformation of the bread is no longer proportional. Now we can see the determination of parameters according to the behavior of the graphics. The parameters that can be determined according to the results are hardness, fracturability, and adhesiveness. In the graphs of the two doughs made, there are no fracturability peaks, but there are in the graphic with the results of the baked bread. On the well, uh, for the first graphic of the dot results, cohesiveness and gumminess cannot be calculated since there is not a second peak to analyze. Here we have the hardness results for the day one for both samples, also the hardness for both samples for the day two, and finally the firmness for the two samples, the one with the complete breed and the other that is only a piece of. Here we have a comparative analysis with some paper of the TPA results. As you can see, here are three different samples, but we are going to concentrate in the first sample that is the control. Also, there are the hardness values of the 3 days that they have the analysis. Here is the formulation and optimal process variables for bread making. According to a study that was carried out on the physical and sensory properties of a fresh bread, there have these variables of bread making. As you can see, there is a mix of the flour, water suspension, salt solution, and sugar. Then they need for 3.5 minutes, and the final temperature of the dough is 27 Celsius. Then they do a fermentation for 85 minutes, and between this process they need the dough 45 minutes after that, and then 15 minutes later, and then finally do a fermentation in a fermentation chamber at 30 Celsius for 75 minutes, and they finally bake the bread at 225 Celsius with a special method of bake, and they cook it for 15 minutes. Then they take away the mold, and they then continue baking for 13 minutes.
As for the conclusions, first, the objective was successfully met as we could gather data of the rheological properties that show that these are affected by the fermentation process. Second, and as time goes by, the dough we have without the fermentation increases in hardness. On the other hand, dough with the fermentation shows the opposite behavior. The third conclusion was that the rheological properties of the dough affect also the rheological properties of the bread after it is baked. Finally, for future replications of this practice, it is recommended to add less water, since it made ours very sticky and a liquid-like texture instead of being elastic. Here we have the references.